Hey everyone, we now have the audio. We got a really full classroom. Hey, what's up, Bradley? So we got everyone. I got some Rick and Morty today. Morty. Can't do a good Rick. No, I just don't. I'm not old enough yet. So let's continue on. If you guys can't tell, you see, here's the worst thing to do is if you're getting trolled. Who watched the Kahoot last night? And did you see where there was like 400, 500 answers in a moment? We started to have people trying to destroy the Kahoot. And so when they were trying to destroy the Kahoot, my brain fizzed out. My brain just left me. And literally, while we're working the problems, in my head, I'm working out what to do if the Kahoot crashes. And I'm coming up with all these backup plans, yet I'm also trying to explain how to solve statistical problems. So that's why I was so scatterbrained at the start, and I wasn't really focused on the problems very well. And I got like 2 problems wrong of my own problems that I wrote. And then what's worse is 3 people then disliked the video when I was getting problems wrong. And I was like, oh, this is awesome. I'm just failing at this. And so everything just started to spiral on me a little bit. But as you know, they didn't crash our Kahoot. They stopped flooding the answers after about question 6 or 7. And then my head started to get back in the game. So sorry about that there at the start. I felt so bad when I didn't know heads from tails, and I didn't know p hat, q hat over n square root over p times q over n square root. Because I did as we often do. We just see something and we start using it. We don't ask, because if it's sampling distribution, what do we use? P times q over n square root or p hat times q hat over n square root? If it's sampling distribution of sample proportion, we use. If it's sampling distribution, I'm 100% sure today, if it's the sampling distribution, we use just p times q over n square root. If we're making confidence intervals, we use p hat times q hat over n square root. And you do have the equations on the sheet. If you get lost on these things, just look, am I doing sampling distribution? That is p times q over n square root. If you're making confidence intervals, it's p hat times q hat over n square root. So be very careful. I also started to freak out too because I thought I had a wrong answer on the Kahoot. Everyone was like, oh, I did the solution this way and I'm getting this answer. And I thought for a moment there was a wrong answer, but there wasn't, which is very good that there wasn't wrong answers, because then everyone's like, oh, I got it right, but I got it wrong. And I'm like, no. But does that make sense there with the sampling distribution? We might do one of those today, but I want to focus today on decision trees to start, since that wasn't in the Kahoot. So this video can be posted. Never let the trolls know that they get the best of you, right? Because I'm like, no, all these people are answering. They're destroying our Kahoot. Then they'll be like, yes, look at his reaction. We got him. So I'm just like, oh, look at those answers. No reaction, right? But can't let them know that they got me. They didn't get us. They didn't destroy our Kahoot, which really makes me worried too, because then I'm wondering, why would someone destroy it? Well, one, was it someone who's taking 201 now that's just like, to heck with this Kahoot and trying to destroy it? Or is it a former student taking 201? Because they had to know where to go. Now, someone could maybe logically deduce like what page to go to and find the page and find the Kahoot code, right? So that's why we don't put the Kahoot code in the chat. That's why we do not put the Kahoot code in the chat. Or everyone's saying like, what is the Kahoot code? Then it would just lead to more destruction. So that is the review of what happened. Do you guys want to do a decision tree to start? We actually really didn't have many trolls in the chat either, which I was shocked. Usually we get a troll or two being like, just saying random stuff. And especially if you guys are, if I know your name, ask me and I'll make you a mod next time, because we always need enough mods to deal with all the trolls. I think, Mitchell, you did a little modding, didn't you? Yeah, so Mitchell was modding. So Mitchell also gets a free 10,000 points for being a mod. That's how he led the way. No, not really. So it's like a dumb joke. People are looking at Mitchell now like, nah, it's not fair. So let's pull up. We're going to hop in here and we're going to start. Yeah, next time, Emily Gaines, just be like, hey, Brian, make me a mod. Aaliyah, you can be a mod too. If you're in there, we'll do a Kahoot for the final. Send me those suggestions. I'm always looking to make the Kahoot better. Just send me those suggestions. Maybe I'll also get the audio from the Kahoot, so that way it shows up in the recording. I need to make sure it's not too loud, though. I might have to mess around with that because I can get the system audio. And so that way you can hear the music while you're watching it as a recording. Yeah, and so we might also get a classroom too. That was suggested. I think classroom would be a pretty good suggestion, so I'll do it from a classroom then. I can even use the green screen then. And I'd even like us to have guest appearances. Like, I'd love it if Smokey like came by and be like, okay, Smokey's doing this question. He like hops in. I gotta talk talk to Smokey. It's a real dog, not a human in a costume, as May would tell you. So I think that'd be cool. I think it'd be pretty funny. And, you know, we got to have a little bit of fun while we're doing it. We're here to learn, but we're also, you know, it should be fun. It should be pretty fun. Okay, we don't want to join with any audio. We've got this going. Let's start sharing the screen, and let's start doing the review. Let's start doing some of that right here. Okay. So thank you everyone for doing that. I think we are good. Okay, cool. All right. Let's start this up. And it was weird. I couldn't actually see what you guys were seeing because my video was lagging. I don't know if it's Comcast or what, or who knows what, but net neutrality or something, but it's wrecking my internet. Wasn't working that quickly. And this person is logged in every time. I need to go talk to them and say, log out. So let's go back here and let's open up some jump. And let's do some decision tree to start here. So we're doing a little bit of decision tree. Now we will have class on Wednesday, but we'll have to kind of end early, and I'll be kind of talking to everybody, and like it'll be like last minute review. Maybe we'll just do it live on YouTube again. Okay, that could be crazy, right? I don't know. We'll see. We'll see if we do some sort of switch up of what we're doing. Again, I need some data. Let me go get the project 2 data. Project 2 grades are appearing. You can see how your project 2 grade was. Let's go right here. Let's go B. Stevens, UTK, Stat 201. So I think the grader has project 2 grades coming up, and they should be finishing them up soon. Thank you to everyone working hard on your project. So let's go over here to projects, and let's pull up the project 2 data. Yes, we can use this one because we use decision trees on it anyways. So let's download the project 2 data. Let's go ahead and click open, and it should open in Jump. Let's go ahead and open it right here, and there it is. So I'm gonna make it a little bit bigger here so we can see, and let's make a decision tree. So the biggest thing with the decision tree is you can make one on your own and analyze it. That's the key to being able to do a decision tree, is be able to make a decision tree and analyze all the output. Make a decision tree, analyze all the output. So let's go here to Analyze, Predictive Modeling, and Partition. And let's hop in here. And I'm gonna do this way. I'm gonna go to original row number, delete. Why am I deleting these things here, like major, original row number? Why am I deleting these? Well, the original row number was a what? Original row number was a identifier. And then the other ones are things that have too many levels. They act like an identifier. If you made a decision tree and they showed up, you'll notice that they, just by the way the algorithm works, which is a little more complex than we usually talk about, it'll bring them in. So you see I have everything selected. What shall we analyze today? What number? You guys tell me. Exactly, Lillian for 50 points, and everyone answering in class 50 points. Emily, Lillian, and Julia, Abby, all of you points. Let's do weekly hours. What number is that? Weekly hours? So weekly hours worked, okay. So you see I deselected it. That way it goes right there. Just so you saw I put it all. What is going on right here? What in the world is this? Why is that 0? What does that mean? Why is that all these black dots lining up there? People who, I think you said it, worked 0 hours, right? So these are people who worked 0 hours. Don't work, exactly right, 50 points in class and online. People that don't work, keep those answers coming up. If you notice here, let's analyze what this means from the start. The average for everyone who answered this survey is 7.9 hours. Do you guys see that? That's what it means there when it says mean, and how many people total do we have? 806, with a standard deviation of 11.002. So that's what all of this information means right here, and then we hit split. And here's what it's gonna do. It's gonna look through every X variable, and it's going to find the best spot in the best X variable to split it. So this is a very complex algorithm. It's actually a modern technique that we use, because back in the day, you wouldn't say, let's look at every variable and look at every way to split them. And that's actually the problem with the categoricals that have too many levels, is there's too many ways to group them up. Does that make sense? If I gave you 500 items and I said, put them into 2 groups, how many different ways could you put 500 items into 2 groups? Like billions and trillions of ways, right? So there's too many ways, and that's why the algorithm will actually find those, because there's some random way by random chance that works when you have these categoricals with too many levels. And identifiers are the same thing. They just don't have any information in them. And also if they're categorical, which they kind of are, they would cause the same problem. So the answer is age. Does this make sense? That people who are older, and this was something on the project, it was like explain the direction of the association. People who are older, i.e. 22 years or older, had a higher mean for hours a week worked. Does that make sense? So the people who are 22 years or older had an average hours of week worked of 17.66. There were 46 people in the survey, and that's their standard deviation. Where the people who are less than 22 years of age, there were 760 of them, and they have a mean of 7.3. We'll hit split. I'm going to do something kind of tricky to make it symmetric. I'm going to split on these two spots, and let's look at what we have. If you notice over here, these are the older people getting less sleep. And what do you notice about their work? What if it said, describe the people who work the most? The people who work the most, tell me two things about the people who work the most. I like this. The people who work the most in this survey are people who are 22 years or older and sleep less than 7 hours. And that's what people online are saying. Basically, I would use specifics if I did on the test. Like if I said write a sentence, I would say the people who work the most are the people who sleep less than 7 hours a night and are 22 years or older. Exactly. Nice job, Lillian. I'm throwing 50 points right there. Nice answer. And everyone else, great answers too. And so how about, and I'm going to mix it up because I want to see one more. Describe for me, oh, that totally makes sense. Wait, what? Oh yeah, worked, okay, good, yes, makes sense. I thought it was sleep for a second. The people, this is a little much. Let's prune below, okay. Describe for me the people who work the least. Let's see. Describe for me the people who work the least. I'll tell you what I would say. People, well, actually, here's the interesting thing. So 22, so be careful. Follow the path. Look at all of these means. Does everyone see all these means? Where is the lowest mean? I think someone got it. And no one's gotten it yet. And Abby, you basically got it right, and Lillian sums it up well. So Abby and Lillian, 50 points each. And everyone else, 25 points for answering, especially in class or online. Think it through, and the answer that I like the most right now is they're less than 22 years of age. Does everyone see that for this right here? And then you notice this is the lowest mean, and they tip less than 22%, which is not a bad tip. But I mean, they are the ones who tip less. So the people who work the least are younger people who tip less. Kind of makes sense, right? Because if you don't have money, you probably wouldn't tip, and people who are younger generally work less. So younger people who tip less work the least. But I do want to do some switching up of this right here. Let's try a little bit of switching up, and let's go to redo, relaunch, and let's take and do hours a night sleep, and then we'll do a categorical here, and we'll look at some split history. Does anyone know what number of hours of sleep a night is? I want to know what that is. Nightly sleep, right? Nice. 60. It's 40. I'll give you 60 points there for taking a guess. I like it. So, and Aaliyah gets it right for 40. I'll give Aaliyah the 60. Let's go split, split, split. Sure, we just let this one split naturally. Who here sleeps the most? It's such a weird one. You did this for your project? No one. Actually, it might be easier to say, who here sleeps the least? Let's do that. Who here sleeps the least? Describe the person who sleeps the least. They are someone who what? I like that. Do what? Liberals who work more than or equal to 25 hours. Less than. It's less than right there. It might be hard to see, but the less than, yep. So a person who says the longest they've ever been awake is less than 45 hours, like continuous. They are liberal and they work 25 or more hours. These are the people, and maybe that's just due to work right there or something, but I don't know why liberal comes into play here. Would you actually, yeah, liberals are apparently sleeping less. I don't know. But very liberals are over here. So it's not like it's pure ideology, something interesting. Who knows what's going on? Yeah?
Okay, so I did this question for my project.
Yep.
And the like scatter plot thing looks just real weird.
This up here?
Yeah.
Yeah, so the way it divides it, it's really hard to see. Do not worry about analyzing this. It's actually like grouping them by each thing. Like this is one split here and this is inside of the splits. Don't worry about analyzing that. Just toss that out. I told some people don't even take a picture of it. It really doesn't add that much information. We can go to the split history. Where's my split history at? There it is. So the split history shows us the increase in R squared. We kind of stop it when it's leveled off. So what is the split history? This is a good question. The split history shows us the increase in R squared after every split. So when I hit split here, it'll put number of splits to what? 4, and then it'll plot where the what is at. R squared. Does everyone see that? And now I hit it again, it'll go to 5, and it'll plot where the R squared is at. Does everyone see how that's working right there? Oh, dang it, it went off the screen. But does everyone see every time we hit split, the split history shows the R squared. And now we could interpret this R squared. We got someone who sleeps a bunch over here. This person, well, it's hard to say what their ideology is, or these 5 people, but these people love taking selfies, and they love sleep. So there you go. And now what would we say? How do we interpret R squared in this tree? So before I hop to this topic, does everyone understand that the split history shows you what? The split history shows you the increase in R squared after every split. Boom, definition right there. Got it, 50 points right there. So the split history shows you the increase in R squared after every split. So the next logical question is, what is R squared? And remember, we're just kind of doing a bunch of examples today to get decision trees down, and we'll post this so people won't be like, I didn't know decision trees. Be like, here's your help. We try to get as much help as we can, so ask those questions too. So how do we interpret this R squared? Can you write it in the chat right now and give me an interpretation of R squared? Imagine this is a test question. Interpret the R squared of the tree in context of the problem. So no, sorry. The definition of split history is, the split history shows us the increase in R squared after each split. So there was asked for a repeat on there. There you go, Emily. And then go, I think I heard interpretation of R squared. Go ahead. Exactly. So make sure to do it in context of the problem. 14.1% of the variation in nightly sleep is explained by the variables in the tree. So remember, blank percent of the variation in Y is explained by the variables in the tree. So that is our interpretation of R squared. So 14.1% of the variation in nightly sleep is explained by the variables in the tree. So does that make sense? 14.1% of the variation in sleep, nightly sleep hours, that's fine too, is explained by the variation in the decision tree. Boom. Or variables, they should accept variation in the decision tree, or just the decision tree, because the tree does the explaining. The whole pathways down it explain the variation. Because you can look at this and be like, oh, this kind of accounts for like why people are sleeping and not sleeping. So that's what the R squared is. But let's hop to a different tree right here. And let's go to relaunch. Did we do liberal conservative last time? Did we do that when we did the lecture? I think we did, didn't we? It's always a fun one to do. I like that one. Did we look at, it's one of the easiest ones. Let's look at the social views one. And what I'm going to do is I'm actually going to remove economic views, because if someone's liberal on one thing, they're generally what? Liberal on the other. Does that make sense? It's really good, and it'll probably show up, so I'm removing it. But the real reason people are, yeah, well, what did you think would show up? What is the biggest deciding factor right now in why people are liberal or conservative? What question could you ask a friend? Does this make sense in your world? The color of very liberal is teal and orange. Which side, left or right, has teal and orange mostly? The left side, right? Does everyone see that? And so this is where, if you look at the colors of very liberals and liberal, and actually you actually have very liberals over here. You have very liberals who are saying things like humans are not influencing climate. Well, this is multiple answers to the question, but I mean, there's a lot of variation. Just because your friend's conservative doesn't mean they don't think climate change is happening, or even very conservative. There's variation on this issue that the media doesn't, I'm not saying fake news. I'm just saying media likes to hype stories and create sides. And they don't show you that a lot of people agree on stuff independent of their ideology. Like there's a lot of agreement between people. Even liberals and very liberals saying, hey, I don't think it's that big of a deal. So it's pretty interesting. Let's split further here. And now, well, what did you think would divide us again when it comes to liberal conservative? The next really polarizing issue in the survey, right? So that's a polarizing issue where you see the liberals going over here saying that Confederate statues should mainly be destroyed or should be put in museums. And then you see the split where there's more conservatives and moderates over here. We'll do another split, and should marriage be regulated? So the most likely place to find conservatives is someone, well, I'm just going to call these two groups here. I know this is a lot right here. To be specific, the people on the right could have answered to climate change. They could have said, it's not happening, it's happening, but humans have no impact. It's happening, but humans have little impact. It's happening, and humans have moderate impact. But I'll just say, these are the people who think climate change is not that big of a deal. If you answered that, it doesn't mean you think it's not that big of a deal or less of a deal. These are the people who think climate change is a bigger deal. Does that make sense? Can we describe just for the moment like that? Okay, just so we don't have to repeat all those possible answers someone could give. The people who think climate change is a bigger deal, the people who think climate change is a lesser of a deal. People who want Confederate statues to kind of go away, people who want them to stay. Does that make sense? Although this person could have said they should be destroyed or should be put in museums. They could have answered that. And then this one's easy. Marriage should not be regulated. Marriage should be regulated. And if we split here, I wonder what we're going to split on. And this is when people started drinking. This one's not as good of a split. I'm just going to remove it. And let's take a look. We can see the split history once again showing us the increases in R squared. So let's look at the split history here. You notice I do have this fourth split, which I didn't end up using. But it is, and look at that. Do you see why I kind of even said, oh, I'm not going to, look at how it goes up and then it levels off, right? So even when I saw it, I was like, it's not that good. So usually you're going to get increases in R squared each time you split. But when I saw how much it went up or what it was doing, I was like, I don't know if I want to use that. So that's why I kind of dialed it back a little bit because I thought it wasn't that good of a split. And so you always have that ability. Once it starts to level off, you want to stop it. That's a much bigger story for a much later day. And I hate saying stuff like that because I want to teach you guys all about holdouts and generalized metrics and stuff like that, but we don't have that time in 201. But let's go ahead right here because we do have a way to figure out when to stop it. The last thing we have not looked at is the leaf report. Look at these crazy leaves. So now when you do this on your test, if you're watching this video now, remember this tip advice for the test. I always say this, when you get a leaf report, number your leaves. I wish the onliners could see this. Go to this, and what do you want to write on this leaf right here? You want to write 1. Over here you'll write 2, and then you'll write 3, and then 50 points right there. You'll write 1, 2, and 3, and they can't see this online. It doesn't show up in the video because you can't see the annotation. 1, 2, 3, 4. Write that on your leaves. Write that on your leaves right there. Put that on your leaves. That is the leaves right there. Put 1, 2, 3, 4. I promise you I wrote them there. You just can't see it. Then when you come down to here, what will you write for this one? What leaf is this? 1, 3, 4. Put that on this. 1, 2, 3, 4. And when you go down to the bottom one, you'll put 1, 2, 3, 4. To be very clear, this is the first, which is associated with this. This is the second, which is associated with this. This is the third, which is associated with this. This is the fourth, which is associated with this. When you look at that fourth leaf, which is barely on the screen, how many very conservatives are in there? You can barely see it. There's the fourth leaf. How many very conservatives are in there? Here's leaf 4, 25. What is the majority of people? What is this big green block? Oh, Aaliyah, it won't actually, it's because the screen, I'm drawing all over it right now, and I wish I could, I need to have a better annotate software that'll let me, it's that, it does like an overlay thing, so I'm annotating for the people in class, that's why I do that so infrequently because you can't see it. I'm sorry. No, I need I got an idea though. Cool, good job. Yeah, take your screenshots and write on it or do something like that. I'm so sorry. I've tried using tablets too, and it's just I've never been able to find a good way. I just wish they could see the things online. Because when I teach in class, I'll usually draw the normal curve out, and I'll put the standard deviations, and we'll draw it out, and we'll figure out the answers. But I can't do that for the online people. So I teach online a little bit different. How many conservatives were there? How many conservatives were there in there? 81. How many liberals in there? 2. And so you see these, and it just boggles my mind. We're doing social. I want to talk to these people who say they are very liberal and they say marriage should be, or they say they're liberal. These people are liberal and they say marriage should be regulated. They're like, I'm liberal on social issues. Marriage should be regulated. I'd be like, I mean, you can hold your view, but are you sure you're liberal? I mean, I'm not saying that's wrong. Do you see the difference here? I'm just saying the liberal view on marriage is usually deregulation and stuff like that, or like, government out of marriage. That's more libertarian maybe, but I'd be like, your view is not really in line with what being liberal means. Nothing wrong if you answered that, but it's confusing. So, but you know what? This person over here, do you see that red right there? That's in leaf number what? That's in leaf 3. And those people right there are what? In leaf 3, those people are what? Very conservative. And they say marriage should not be regulated. They're like, I'm very conservative on social issues. And like, marriage should not be regulated. I'd be like, well, you sure you're very conservative? Maybe you're conservative or moderate, like, at least on this one issue. But there's a lot of other issues. Maybe this is like their one issue, and we do have a larger sample, right? So maybe they're like on abortion and other LGBT equality issues. Like maybe they're more very conservative. Maybe the liberal person, that's really like their one issue where they differ from the party lines. So who knows? But it's interesting to me when we see things like this, that these 7 people right here, they said climate change is less of a deal, and they said marriage should not be regulated. And at least climate change being less of a deal, that is more of a conservative position. Does that make sense? At least when we think about, of course, I think about it scientifically. That's a whole nother story for a whole nother day. But just on party lines, you usually see more of a conservative, climate change not a big deal, liberal, climate change bigger deal. So very interesting right here with this data. Let's do one more tree right here, and let's try some tricks on it. Redo, relaunch. The more trees you look at, the better you get at analyzing them. If you're watching this video now, go back to these trees and analyze it. Why not? Let's do gender and see if we can explain why someone is male or female. So that looks like, oh man, who here wants funfetti cupcakes? They're just sprinkles, right? But they're the best. I don't know what it is about those it's gone now. We lost our funfetti cupcakes. Look just like it. Okay. Oh, this is kind of cool. I like this tree. Okay, this is a great tree. What colors are males here? And I think we don't need that last. Maybe we do need it. Males are blue. Females are red. And that's so weird where the first split goes. Oh, no. Okay, it goes what I thought. Expensive coffee. There you go. I thought it was reverse of what my expectations were. So who is spending more on coffee, generally speaking? The most expensive coffee they've ever bought. Generally speaking, females. Does everyone see this group over here that is more female and this group over here that is more males? Does that make sense? And this doesn't explain everyone, because this only explains 17% of the variation, or 16.8% of the variation in somebody's gender is explained by the decision tree, or the variables in the decision tree, something like that. Now, what do we see over here? Where's our next split inside of here? Remember, on what? On how many selfies someone takes. And we see the people buying expensive coffees, there's my New York accent, and taking selfies with those coffees are mostly females. Tell me about these guys right here. Tell me about those gentlemen. They buy what? More expensive coffee, and they take more selfies. So remember, this is just trends in the data. It doesn't explain everything, but the trend in the data is people who buy more expensive coffees and take more selfies are generally more likely to be female. Does that make sense? Where people who buy less expensive coffees, and let's split this one here just to get, and males are staying awake super long. And what else? And males are not doing well in high school. Describe to me the quintessential male. And then we'll describe the quintessential female. We'll split here on this one. Describe to me, it doesn't sound good for either of them. It's not, and then you might have to look through all of these. This is a much larger, we kind of went from easier. The numbers, okay, so the numbers we wrote down earlier, go to the bottom for the leaf report. Leaf 1, look where I'm hovering. Leaf 1, 2, 3, 4, 5, 6, 7, 8. Because I split it apart 7 times. If you split something 7 times, you make 8 groups. Does that make sense? Because how many do you start with? You start with how many groups to start? 1, so every time you split it, you get 1 more group. Does that make sense? If you split it once, you get 2 groups. Describe for me and so I think that helps everyone understand. Describe for me the most likely person to be a male in this data set. Go ahead. Which isn't that bad. I mean, maybe they had a 3.9, right? A high school GPA of less than 3.94. The longest awake for more than 18 hours or equal to. They've spent less than 4.75. I'll repeat all that. They've spent less than $4.75 on coffee. They buy less expensive coffee. The longest they've been awake is greater than or equal to 18 hours. They stay awake longer. And their high school GPA is less than 3.94. That is the most, if your friend's like, I had a 3.8 GPA, I've stayed awake 40 hours, and I don't really drink coffee, so I guess it was $1. Like, you're probably male. And they'd be like, well, yeah, because you're talking to me. But that would be a more likely person to be male. But do look over here. Do we have any females in this category? We do. How in the world would I know how many females are in that category? Go to leaf report, which tells it tells you about the leaves. That was leaf number what? 1. It's the farthest on the left. Make sure on your leaf report to write 1, 2, 3, 4, 5, 6, 7, 8. And that would go with 1, 2, 3, 4, 5, 6, 7, 8. The bottom terminal leaves are the ones in the leaf reports. So 9 at an 81 right there. That is 9 out of 81. And they do these, we usually remove that one right there. Whoops, the full leaf report. I wanted to remove that one. The way Jump does these calculations are a little bit different. Don't worry about using this. We'll give you these numbers. So there are 9 females right here. That little red speck right there, the little red chunk is 9 females. Does that make sense to everybody? How many females are there right here? Out of this 155, how many females are there in that? Tell me that leaf is a combination, which this isn't a terminal leaf, like an ending one. That would have the values from leaf what and what in it? 1 and 2. So why don't we go look at leaf 1 and 2, and how many females are there in leaf 1? How many in leaf 2? So if I did this right here and made this now, how many? 25 and 9 is what? And what do you notice? Boom, right there. I think that's on the practice test too. Like how many people report this? So you could, if you wanted to add up this right here, imagine we want to figure out how many females are in this leaf right here. Do you see this one? So how many females are in that leaf? What leaves do we need to add up to figure out how many females there are in this 287? I think you're right. 1, 2, 3, 4, 5, and 6, because those would all go back into that. So once again, 1, 2, 3, 4 goes into that, 5, and 6. So does that make sense? 4, 5, and 6? I think you'll see it right there. So let's go down. In leaf 4, there's 91, 25, and 64. So I wonder if I can do this on the PC. So 91 plus 25 plus, oh, it does. Thank you, PC, for being just as good as Max. There we go, 180. So you see, all I did was add up these numbers in leaf 4, 5, and 6, because it's leaf 4, 5, and 6. You can't see it behind there. It's 180. And when I prune right here, that is now leaf 4, and leaf 4 has in it how many females? 180. Does that make sense, how I'm getting these numbers? Now I can figure out stuff like this, how the leaf report kind of works, and how we're interpreting what these splits mean. Does anyone feel like they understand decision trees a little bit better here? We did a quantitative, we did a categorical. Good, I'm glad to hear that. I wanted to review decision trees. You sometimes have to see something twice. That's why we got so much time. We got so much time before this test. I'm gonna kind of let you guys take a hold of this. We talked about what the leaf report is. It just shows you the values in each terminal leaf. Make sure, as we said, to number it 1, 2, 3, 4, 5, and then number 1, 2, 3, 4, 5. And it's literally just saying, letting you see the females here, the males here, and there's the females. If you notice, it looks just like this. And you can also see where the amounts are. Also, if you look at this graphic here, look at the leaves. 1, 2, 3, 4, 5. Which terminal leaf has the least amount of people in it? Leaf number what, looking at the graphic? Use the one with the numbers. I can't remember if we gave you both, but only use the ones with the numbers. They're saying terminal leaf number 2. Look, this is number 2. You can write 1, 2, 3, 4, 5 on this. 2 is right here. And look, you can literally see I can't tell if that male's in that leaf or not. It's so hard to tell. Let me expand this. That male is not inside of there. Does everyone see these 2 dots right here? This is leaf number 2, and it has 2 males. And look, that number 2 right there is leaf number 2 of the 14 people. That is those are those literal 2 males. If you were to, you could count up every dot if you really wanted. Not a good way of doing it, right? But these are the 2 males right here. These 2 dots are the 2 males in leaf number 2. And it goes the same right here, that this is read left to right with leaf 1, 2, 3, 4, 5. And then this is read 1, 2, 3, 4, 5. And then this is read 1, 2, 3, 4, 5. And we saw other ones with quantitative. I don't think I did a leaf report for oh no, I lost my decision trees. I like hitting that redo button, it's so good. Point click software is pretty good. It has its benefits. Sure, let's see who's born. No, I'm gonna do another quantitative. High school GPA, sure. Quantitative, and if you wanna clear these colors, you can always go to rows, clear row states. There we go. And let's go split. And here's high school GPA. If you do the leaf report on this one, it mainly just reports the means and the standard deviations, or just the means. So really there's not too much extra given to you because it's just in the leaf itself. The one where you really get the best info is with the categorical. And also, if you notice here, I was using categorical Ys and categorical X's because we were doing things like, were you born in Tennessee? Actually, we didn't do that one. We did your views, which are categories, liberal versus conservative. And then we did we did someone's age, which is quantitative, and high school GPA, which is quantitative. And then even in here, you see a categorical X and a quantitative X. So decision trees take all kinds of variables except identifiers or things that act like identifiers. That's the ones they don't take right there. So let's let you guys kind of take a hold of this review right now. We'll probably be doing as much review as we can next class. So we'll probably be here at 5:05. I think we're doing it in G2, right? Here's my plan for next class. The test is in G2, and I'm pretty sure the printers have it. I sent that email. They don't send me confirmation. I'm printing 1,000+ tests. I would like a confirmation. Thank you, printers, very much. Just waiting for that one day when like, you sent us a thing, it got sent to our spam box. I'll be like, oh my God, no. But I'll make sure it's printing. But I mean, then you guys don't have to take the test, right? Yeah, then I'm in trouble. So next class, we will meet up here to start. Mitchell will be getting his $10 in Starbucks gift cards. So, and also Madison, I think I owe another one too. It's nice that someone's in our class. I didn't plan for that. And also I plan on bringing the gross jelly beans before the test so we can talk more about probability. We could do one of those now if you wanted. Maybe I'll do that before the test too. We'll try out the gross jelly beans and like, what are the odds you get it 2 gross or like 2 gross in a row. That's a really good way to practice probability with the jelly beans. If you just say the probability of a gross jelly bean is 30%. I know they're so bad. You know, the ones that are not bad are like grass clippings. Have you ever had the grass clippings one? I'll eat one of those right now. If someone it's like, here's a grass clippings jelly bean. I'm like, oh yeah, that's cool. Grass doesn't taste that bad. Or toothpaste. It's toothpaste. You put that in your mouth every day. I mean, it's not like you want to eat toothpaste, but you realize it's food. It's candy that's meant to taste like toothpaste. But the thing like, what is it? There's like molded rotten cheese or something, or molded, there's barf. The worst for me is the fish one. There's like a fish one or something. That's so bad. Oh, skunks. Oh yeah, skunks. The fish one's horrible. And the milk one, the like spoiled milk. Oh, I will, what I do to eat that, rotted milk, is it? Oh God. I will bite into it one moment with my tooth, and if it tastes bad, I will swallow it. And even then it's still bad. I cheat. That's totally cheating, isn't it? I ate it, but I will not chew it more than is needed. I'll bite, I'll taste it, and if it's bad, I'll swallow it immediately. That's the key. If your friends have you do it, just bite. Yes, Emily knows the trick. If it tastes bad, just tasted a tiny, swallow it. Oh no, Madison, Madeline pranks her boyfriend with those. What topic do you guys want to cover? That's our good 2 minutes of just getting it out there. Just swallow it. I swear. How about not even biting it and being like, oh, it was so bad, you just swallow it. Like, here, try this jelly bean. You don't even taste it. That's what you do. Difference between strata cluster and simple random, and then we'll do a sampling distribution one. Okay, so let's see right here. I really like the examples with strata cluster, and let's look at, so I really like this right here. Now, here's some key difference with, am I gonna go buy this now? Sure, let's go buy this. So, oh, it's family size for $5. That might not be that bad. You can still get over a pound. That's like a 1.2, 1.3 pounds of M&Ms for $5. That's not bad. My last quick story, I used to go to this place called Tops in New York. Does anyone know Tops? Their motto is Tops never stops saving you money or something. Dumb motto. But they used to have candy for like $3 or $4 for gummies. Like a pound of gummies was like $3 or $4. And man, I would just go there and get like 4 pounds of candy, and we'd watch a movie or something. And you just eat like 4 pounds of candy. I don't know how I don't have diabetes. So you can get 48 packs of Fun Dip for, oh no, don't tell me that. I'll be buying Fun Dip. Okay, anyways, what is this big, humongous sample right here? This is more analogous to a what? If we take it and we do a census on it, and we take a bunch of bags, and this is one of the key aspects of one of them, we need something that's a large group, and we do a census on it. That's a cluster. The key is you do a census on a cluster. What does a census mean? To sample how much of it? All of it. A census is when you sample all of it. So a true census on a population like the US Census is to get everyone in the population. Now, what we do is a census on the cluster, as in we do a full sample. So imagine you work at the M&M factory, and they said, we want to see how our quality is doing. Go grab about 10 bags. Would that be a good way to see how the quality is doing? Not so bad. I mean, that's all right. You could grab 10 random bags of M&Ms. Now, we picked the clusters randomly. So one, this is kind of the three things here, and I think that's a question too. One would be things are put into groups randomly, which do you assume that about bags of M&Ms, that they're kind of put there randomly? Or do we put all the bad M&Ms in one bag? It is randomly. I would say we probably put the M&Ms into random bags. So any bag of M&Ms is kind of a random grouping of M&Ms, right? So they need to be put into groups randomly. Two, randomly select the clusters. And then three, and this is the key aspect to remember, because it'll help you to know it's not strata, you always do a what on the cluster? A census. And that's one of the key things, as I've taught this class, I think helps people differentiate between a cluster and strata. Would a cluster involve other smaller groups like a big bag? Yeah, and those can be cluster. Ooh, careful. Those can be clusters too. It can be a smaller bag, because still that's just a cluster. Like I talk about boxes of donuts is a cluster of donuts. 6 packs of soda or a cluster of our cans at our factory. So imagine we want to say, we think the machine is damaging it, the machine that puts it into the 6 packs. So what we probably want to do is take 6 packs before and after or we might take 6 packs after they've been put through the process, and we could see if they have any damage on them. Like, are our cans damaged after they come through the packaging machine? So you could take these 6 packs of Coca-Cola and just do an analysis of each 6 pack. Like, it has 6 samples in it. I hope that helps differentiate. And last night I was talking about donuts, because when you go to Krispy Kreme, if you want to get a whole bunch of donuts at once, you could just order a what? A dozen. And there are 50 points right there. I love those answers. Would you assume that they gave you the bad dozen, or they put all the bad donuts in one box? So a dozen donuts from Krispy Kreme is probably like all other dozens, right? It's a random dozen, right? Would you agree? It's not perfectly like all others, but this dozen is probably a representation of what you would expect to get if you got another dozen. And that's the key. Now, the difference here, and we can stay with donuts for a second, which I use all the time, is when you go to strata, you first start by identifying a difference in your population that you want to control for. When you go to Krispy Kreme, I think the best thing to control for is your baked versus your glazed donuts. The glazed donuts come out of that big production machine, right? Has anyone seen that? Like, let's look that up just so everyone can see. One person has not seen it. Krispy Kreme donut machine. That thing is huge. Oh man, we'll just watch a video. Oh, no. If I play a video, I can get hit by a copyright claim. And I had that happen one time. See, look how happy that kid is. That kid's like, I'm gonna get all those donuts. You ever see that one donut that doesn't get baked properly and it's like, didn't get flipped? I wanna eat that donut. I don't know why they won't let you have it. Oh, there it is right there. That's that donut that didn't flip, I don't think. I'll eat it. I want to try it. I'll eat that half-baked donut. Oh my, you guys look at this. It's got, did you say ooh? I'll take it. So, and they're saying ooh online too. So there's some burger online that has, oh, you can get like a homemade one. In-home donut machine. No, no. So exactly, and a person who even loves donuts. So anyways, we have the donut machine now, and this donut machine is going to have a different level of quality. I want to try one of those right there. I'd eat it right now. Let it burn my mouth. Man, I'm so hungry today. So the donut machine is probably going to have a different level of quality than our donuts that don't come from the donut machine, right? So if someone said, how is our Krispy Kreme doing? We probably want to say, well, 30% of our sales are from regular donuts. We're Krispy Kreme. We sell the glazed donut. Everyone knows us for that. 70% of our sales are from the glazed donuts. Let's take a sample of 200 donuts. Do you see what I did first? I identified a difference. I said, well, we have our glazed donuts, which are 70% of our sales, and then we have our regular donuts, which are 30% of our sales. Identify the difference. And my gosh, we have like the ladies' donuts. You guys see that? And then they're opening up a Krispy Kreme right across from her, like Zoe's Donuts, and literally across the street's a Krispy Kreme. That's insane. That's some strategy right there. Judy's Donuts. I want to try Judy's Donuts. I hope they're good priced. Can't have too many either. I agree. So once we identify this difference, oh, they got a New York cheesecake. That's not fair. That's what that is right there. Once we identify this difference between the donuts, we will then sample our population accordingly. As in, if we sample 200 donuts, I'm throwing the 1,000-point question of the day. How many of those 200 donuts in either hand raising class or online, how many of those 200 donuts should be glazed donuts? 1,000-point question of the day. How many of those glazed donuts how many of those 200 should be glazed donuts? You had to be listening to the numbers I gave earlier. Boom, Abby gets it. Wait, Abby got it. I'll throw everyone else 50 points, but Abby, you were first for the 1,000-point of the day. The answer is 140. Oh no, Emily, 50 right there. So first in class, I'll give you 200 for first in class. So it is 140. Why? Because I told you what percent of our sales are glazed? 70. And then I said 30% are baked. So we go right here and we say, okay, 70% are glazed. We're sampling 200. That means 140. And now listen to the big key difference here. One, I identified a difference in my population. Two, might be easier this way. Two, I then sampled in accordance to those percentages of the difference. Does that make sense? And how would I get these donuts? I would select them randomly. Does that make sense? I'd randomly take, and you could take boxes. I could take, and then I'd have cluster with Strata, right? So I'm taking so many boxes of, this. So if it's 70, I just take a lot of boxes. I could take 35 and 15 boxes, but you could just sample until you get enough. But the boxes would be the cluster. The difference between the glazed and the baked donuts would be Strata. And the biggest thing here that you should note, are you going to take every glazed donut? Because that's an element of what? Cluster, right? 50 points right there. Because in Strata, you don't take the whole Strata. You don't say, let's sample all the glazed donuts and all the baked donuts. You say, let's sample within those Strata. I think the hardest thing here is both of them deal with groups. Like in cluster, you're taking a whole group and doing a census on it. And in Strata, you're identifying a difference to create groups. And then you're sampling within those groups kind of with simple random sample. How do we get our clusters? Simple random too. We number all the clusters and take a random cluster. And that's not a multi-stage. It's just, you wouldn't take the first 10 boxes on the shelf. You would take random boxes throughout the day. You'd say, okay, we make 500 boxes in a day. Let's take the 50th box. Well, you go to a random number generator, like random.org, and then you would take random random right here. You'd say we make 500 boxes throughout the day, probably an underestimate. Here, we're going to take 30 boxes, and these are the numbers of the boxes we're going to do an inspection on. And you wouldn't tell your employees, you would just do a random inspection of a box to see the quality and how they're doing. So you might just have someone come in. You might have a secret shopper or something who comes in. Kind of weird when they keep coming in like 10 times a day, right? But you'd have someone come in, get these box of donuts and see how it's doing. Because especially, and this just goes to research, if the people know that you're going to be examining a box of donuts, do you think you're going to get a truly random box of donuts? No. So if you want a good random box of donuts, you shouldn't have that. And that would probably be what kind of bias? Ooh, that's a tricky one. 100-pointer right here, that would be what kind of bias? You might weasel a different one here, but what kind of bias would that be? I would say, do what? I was thinking that could be one we could use. You could, yes, I do think it could work towards voluntary. I was going to say response bias because they're not answering it honestly. They're cheating with what the responses are. They're altering the responses. They're altering the data you collect, which more goes towards response bias, I would say, because it's not the true response. Because if you want to see how many of the donuts are overcooked, and they give you all the best donuts, they're altering the response that you're analyzing. But yeah, I would say it's more of a response bias. That's a tough one right there, because the response goes to the information you collect on them. Does that make sense? And they're cheating the information. But I do think voluntary, that's why I would never make this one a test question, because they're kind of volunteering the donuts they want. Also, if you chose the first 10 boxes off the shelf, you've done a cluster sample, but you've also added in an element of what? Why is that not a good cluster sample? Because it's cluster with what? First 10 boxes would be cluster with convenience. So that your clusters should be chosen randomly. That doesn't make it cluster with multi-stage with simple random. It's just when you choose clusters randomly. It's an element. It's how you get your clusters. Yes. So I heard there was a sampling distribution problem next. Does this help differentiate between strata and cluster for people? Question in the back too. Systematic? Mm-hmm. Systematic sampling is choose a random starting point.
Yeah, but are we going to have to worry about like the specificity of choosing a random starting point?
Usually we say that. Usually I know it really needs to use a random starting point. And I'll explain briefly here why it should have a random starting point. Because if you're taking multiple systematic samples, and if you had it start at the beginning of the day, imagine we had like a roller, and every fifth thing on the roller was like a mess up, like we're printing the M&Ms, and we took every fifth M&M. Well, either we'd be directly on the error, or we'd be off the error and never see it. So if you were to sample your M&Ms randomly and choose random starting points, then you wouldn't have some sort of time-oriented error that takes place every kth observation. So you'd do more systematic samples and you'd randomize your start. The true systematic, I don't think it'll come down to that big of a deal. Usually we just say it, but don't think that that's a multi-stage to choose a random starting point and then choose every kth observation from there. But that's why we choose a random starting point, to eliminate any sort of time-oriented systematic error. Because if you were to take multiple, if this was like your sampling plan for your factory, every day you would pick a random starting point. Does that make sense? But if they said, oh, let's start on the first one every day, you might be on some sort of systematic error then, or off some systematic error. It wouldn't give you a good idea of the process. So we usually are very specific on that. Random starting point, and then select every kth observation, and it should be specific. If you're confused on the test, ask me and I'll clarify if the question is not specific enough. So good questions. We have enough time for a sampling distribution one. Sampling distribution or confidence interval? Sampling distribution, okay. So let's do the sampling distribution right here. Let's write up a problem and let's solve it. I'm gonna basically make this a problem like the test problem. So if you've done the one that is on the practice test with the air conditioners, we're gonna do something similar to that. And let's see right here. Let's do one similar to, okay. Oh, yes. No, let's say a Krispy Kreme. So a Krispy Kreme factory knows that the proportion of donuts that are undercooked is, that's correct grammar, right? 0.12. A worker at the factory decides to take a random sample of 100, oh gosh, I took a lot of donuts there, donuts to see what proportion undercooked, and find that 9 are undercooked. Don't worry about the grammar here. Let's do this. That's pretty much all the information. 1, draw the sampling distribution of the what? The sampling distribution of the sample proportion, sample distribution of the sample portion. Let's add in a quick thing here too. Let's do this. 1, check conditions to see if we can use the normal model here. So remember, to meet the conditions, we must, or excuse me, to use the normal model, we must meet the conditions. Condition 1, random. Do we meet it? What would you write on the test for this? You'd write random for the condition, right? And then you would write, this is literally teaching the test, but hey, you got it, the test is coming up, right? So then you would circle, yes, we meet it, and what would you write? Question says it's random, so it's random. I mean, best we can tell. We're not trying to trick you. It's not like, no, they didn't, they thought they did, no. The question says it's random, we're good. Condition 2, less than 10%. I also accept 10% condition, or basically 10%. We should all know what that means, but now we have to explain. Let's first explain what the 10% condition is. What is the 10% condition? It says we must, yep. And there is the finite population correction factor that which we could use, but we don't teach that in this class. There's always more statistics, and people have found ways to make the problems work. But with this finite population, the way we're using it in this class, we have the less than 10%. And let's think, we're a Krispy Kreme factory. Do you think logically what here? We're a big factory. Let's say this, a major Krispy Kreme factory that supplies donuts across the US. There we go. So we make lots of donuts, so 100 is less than 10%, yes. 100 donuts is definitely less than 10% of all donuts we make. I'm just trying to add as much context here that yes, 100 donuts is less than 10% of all the donuts we make. That's pretty much what we need to say there, that this amount of donuts we are sampling is less than 10% of all the donuts. Condition 3, use some numbers on this. Let's see those numbers in the chat. Condition 3 states what? NP and NQ are both greater than or equal to 10. And I like it, they're saying success failure in the chat. And the biggest thing here, make sure you pause for a moment and ask yourself, is this what or what? Categorical or quantitative? And a big way to identify too if it's categorical is if you see sampling distribution of sample proportion, or if it's quantitative, sampling distribution of sample mean. Does that make sense? So if you see sample mean of sampling distribution of sample mean, quantitative, and then we are using large enough n, which states if it's normal, 1, if it's skewed, 25, if it's heavily skewed, 100. We might have enough time for one of those after this. So condition 3 is success failure, and success failure states we need at least 10 successes and at least 10 failures. So Madeline right there, condition 3, success failure, meaning we need at least 10 successes, at least 10 failures, and how many successes and how many failures do we have? We have how many? 12 successes and 88 failures. So, and just do your math, kind of show it, which is, if you wrote that, you'd be good on this. So this is right here, there's the successes, and then the failures is 0.88 because the complement, oh, and that equals 88. So P, and here's the thing you should also do. Can we put notes? How do you go to put notes? I never put notes and stuff. Where do you go to put notes? Where do you go to? You go to reference? No. Where do you go to put in notes? Who knows how to put in notes in these? Or is it insert? Let's go to insert. I think you're right. And does anyone see notes on here? Comment. Where's comment at? Right. Thank you very much, both of you. 100 points. I like it. Tell me what to do with the comment. There. Wait. Why is it commenting on that? Oh, that's. Oh, great. This is awesome. Good. So if I highlight this and I comment on it, you should on your test put N, not big N. Oh my gosh, what am I doing? I was looking at the next one. Is anyone yelling in the chat? Nope, not yet. P. And then right here. And I thought it would look better. I guess not. So let's do it this way, because I thought it would keep these up as we were looking at it. I wanted it to keep the comments up, but that didn't work. Sometimes you try something and it just doesn't work. Let's go right here and put P next to this. This is the population proportion. Let's go ahead and put little n next to this, which stands for the sample size. Big N is the population size. And then let's go right here and put what next to this? I don't know, apparently today. It is, what is this? What is 9? What is it? It's X, right? So I think if you right click, it'll give you, I should have done that. I'll might use it next time. Bradley and Madeline, another 50 points. Keep those answers coming. So this is X, this is N, this is P. So what if the next question said, we're inserting some new questions. What is the sample proportion? What is the sample proportion? I think you guys got it. It's X over N equals 9 over 100 equals, and then that equals 0.09. Does that make sense to everybody? Make sure the sample proportion is given as a decimal. So it is 0.09, which is 9%. It wouldn't be horrible to write it as a percentage, but it's 0.09. X is 9, N is 100. So it is 0.09. Now here's where we have to be careful. Don't make a mistake like Brian. We could also put in here this. We could say, thus Q equals 0.88. So we know P and Q, technically they're lowercase. P and Q. P is the sample the true proportion, excuse me. I was just doing sample proportion. P is the true proportion. Q is the complement of the true proportion. P and Q add up to 1. So now we do P times Q over N square root. And what will that give us when I do P times Q over N square root? And let's pull up the formula here so we can see. Sure, why not? Wow. P times Q over N squared. Cool, you can see the math right there. Let's go this standard. There's right there. And we should see a formula for it. P times Q over N square root. Here it is right here. Got a little bit differently written than we have it, but basically the same. P, and there's Q, over N square root. And they're using P bar. I don't love that. P times Q over N square root. Man, people love changing that notation. So P times Q over N square root. And that gives the standard deviation. What is the mean for the distribution? What is the mean? Well, what is P? Bradley got it right there, 50 points. It's P, right? I mean, the true proportion is what we'd expect to see. If 12% of donuts are undercooked and you took a sample, what would you expect to see? 12%. So let's put that in the center. So you can see right here, we're going to hop over to David M. Lane right now. We don't need the calculator anymore. So let's hop over here to the David M. Lane. And everyone always says to me, Brian, and it's all right that they ask this, but keep asking it because it's a common question. They say, how in the world would we draw this on the test? On the test, you should put your mean at the center. Put your mean. And then you should go up and down the standard deviations. Oh no, I lost my number. Oh, we can find it real quickly again. So P times Q over N square root. Got it. And there it is right there. And you know what's really interesting? What is the z-score almost for what we saw in our sample? In our sample, the z-score looks to be very close to what? I blocked it there. The z-score is just a little bit less than or greater than, you might be seeing it online. Hang Mitchell said it. So let's hop this over. We're going to put this in our drawing right here. So you could draw this. You'd put the mean in the center, which is p, and then you'd find p times q over n square root and go up, up, up. You just add it to it 3 times, and then you go down, 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 just subtract it from it 3 times, and you've drawn the sampling distribution of the sample proportion. And now question number 4 might say, what is the z-score for their sample? And it's basically what? Basically what here? Just you look at it and just try to figure out from looking at it. Pretend you know nothing from the class and be like, well, he saw 9%. That looks to be a z-score of what? -1. Did everyone hear that? -1? Because it's probably a little bit less than that or closer to 0, because negative or 0.09 would be right here. So let's go and check this out. The formula will be, I'll write it in here on the slide. I'll actually bring up a formula. The formula for the z-score is, let's go to insert formula equation. We need to go equation right here. Word is not loving us today. And so the formula is observation, which is p hat. Let's go right here. Seeing which came first, observation minus mean over standard deviation. You notice when we say observation minus mean over standard deviation, we observed a p hat, which is our sample proportion. We expected the, oh my. Yeah, I didn't know that would happen. I need to go over one more, there we go. So we observed a sample proportion. We expected the true proportion. And then we need to do the standard deviation right here. That bottom part is the p times q over n square root. And that would be that right there. So does everyone see this right here? This is equal to the z-score. And we'll put it in the center right here. Make it look all nice and neat. And then when we put in our numbers, what we would get, another equal sign right here, equals. Solving this out, we observed 9%. We expected 12%. And that's just the difference. And just look, that's how far we are away. Now we go and we take our, it's the 3rd time today, p times q over n square root. So p times q over n square root. And we just take this and we drop it into here. The top of the equation is negative 0.03. Does everyone see that math right there for the top of the equation? And let's go right here and go negative 0.03, divide by this. And there we are as our answer, and that's in line with what we thought. And let's just write this all out right here. So we'll put another equals right here. And then the top of the equation is negative 0.03. And let's take a look at this right here. Observation minus mean over standard deviation, and that will give us the answer to this question. And last but not least, we have our answer. Let's bring it up here. Let's go right here and drop in the answer, and there it is. And does that look to be about where we're at about a z-score, meaning we are about 1 standard deviation? It's a standard deviation because we know the truth right here. We know the true proportion. That's about where we're at. So this, and the last question might say, is this unusual? Let's do that. Is this unusual? Is it unusual? No, it's not unusual at all. And where we might think that things are unusual is plus or minus 2 standard deviations. So this is not unusual because it's within 2. It is truthful that it's not unusual because it's within 1, but 2 is where we start to think things are unusual. There's a good question I saw in another practice test. Sometimes teachers come up with their own examples, like I come up with mine. So you get different examples from different instructors, just because we're all trying to come up with different stuff, what we think will help you best. Well, we have one unified practice test. But the question said, 95% of random samples would produce results within what and what? 95% of random samples would produce results between what and what? Yep. And the answer is 2 standard deviations, and in context would be 95% of random samples would produce proportions of undercooked donuts between 5.5 to 18.5, or 0.055 as a proportion, 0.185. And this is what would happen if we went out and sampled. 95% of the time, a random sample would be contained within this interval. A random sample if the truth is 12, because this is just what would happen if we sample. That will do if you guys want anything else. But that was a good question right there. Good sampling distribution. Make sure you know how the sample mean works. Any other quickie questions that you guys have? We'll see if there's any more. Go ahead, Megan. Hmm? Nah, we probably won't do like the because the percent would be a little more than 32%. You could say that, because we're right here, right? You could say this would occur, something as low or lower than this would occur about 32% of the time. Oh no, I'm making a mistake. Sorry, that's 16%. I need food. But 32% would be the outside of the curve, outside of -1 and +1. So it's not that unusual. It's a little low. Does that make sense? But it's not very unusual, because at about 2 standard deviations, we start to say things are pretty unusual. And that actually goes with a p-value of 0.05 when we do p-values. A p-value of 0.05 on a two-tailed test would be outside of -2 and +2, technically 1.96. But no, it's a great question. I like that for 50 points. Does that make sense? And so you could kind of mention that, but the quickest way to say if a z-score is unusual, the magnitude of it needs to be greater than 2. So if we had something like 2.5 here or 2.8, would that be unusual? How about 1.2, 1.8, 1.9? And we're probably not going to play that kind of game. Usual will be nicer. Like this one is probably a good test problem because it's -1.9 or -0.9, which is within a standard deviation. So that's not unusual at all. Like that's like, oh, that could happen. It's like if your friend's like, oh, I did so poor on the exam, I made a 70. And you're like, well, that's a little bit below average. And the average is maybe a 78 with a standard deviation of 8. That would make their z-score what? Exactly -1. So, and you're like, well, that's not so bad. You know, we're 1 standard deviation below the mean. So that's got it. We got more time if you guys have more questions. I hope this helped today. And definitely, I'll probably be putting this out on the main channel as like, hey, check it out and review time. But email me those questions. We'll be doing some really focused review before the test. And then we're in the home stretch with like 7 more classes. And maybe, just maybe, I'll be broadcasting a grading about Project 2 grading. Email me that. Or if it's a general one, I guess I can answer. But yes. Then I might be broadcasting again from Kingsport for the one before Thanksgiving. That's always a fun one. You guys get to see dogs and everything. Oh no! I'll come back in 1 second to look at the chat.
And then don't mix it with missing scatter part. That's weird. Or like, so are you removing it in the last couple words, and it would be an outlier, and would be.
Scroll down. Scroll down.
There's nothing. And then like, there's also like need to report R-square, need to report p-value, but in the option for the project, it doesn't ask for the actually reporting the numbers. Well, it says for R-square, but it doesn't say.
I think how do you know that? You said the p-value is less than 0.05? Yeah. I think you must be there. So let me read your answer again.
I said like the percent.
Yeah, I think that's fine right there. I know you did. We don't want someone to say that the worst thing someone can say is that p-value is less than 0.05. But since you were specific there and said, so definitely that one right there. But you say, I think you're fine. You report R-squared by giving the number. So these 3 right here. So are you removing it? Let me read this. Okay, so there's one outlier where a person can say, did you remove it though? Did you reproduce it?
I removed it, and then the actual numbers I used are from the rules.
You just didn't reproduce it.
Yeah, I didn't realize
I
that.
think it says to reproduce. Go back and, as it says in the project instructions. Examine, make sure to include, if you have any data points, make sure.
It says generate another scatter plot, but it doesn't say included.
No, we do. So that one I think, but no, I think that's just, we should say include in the report, but anything you generally want to include. But the other ones I'm definitely with you on. Go back to so I wonder where he took off more points on. Let me see.
So he took off half a point for like misdoing the numbers.
I don't know why
I don't know why I did that.
I don't care at the numbers.
Yeah, like the number.
All right, so 1, scroll down again. 1, and then I'm gonna give you a half point back on this. So that's 1.5. Okay, that's
he's
3, 4, 4.5.
5 points there.
Oh, it's 5 points?
Yeah.
Wait, what is it? He says you're missing the scatter plot.
And the scatter plot's like right there, right?
Yeah, I don't understand. I don't know if there was a problem with the output or something with
I think that because the numbering, he thought that it was like maybe I didn't label it as 5A.
Well, yeah, maybe when he was just Well, so yeah, that's okay. So that's 5 right there. Actually, no, I'm gonna keep that half point off. That seemed to be an issue, right?
Yeah.
Because it confused the grader. So we'll leave that one off.
Yeah.
5, 8. Yeah, and then tell me 9. Email me, hey Brian, 9 points back on project. Okay. Ew, and then I think I have a question. Yeah, email me, Madeline. So yeah, if you think there's anything about grading, then just email me or swing by my office hours and we'll take a look at it. And obviously, if you heard the conversation with Random Student, I'm always open to your guys looking over the comments and what you think. And because grading is, it's not perfect. It's usually pretty good, and it has been pretty good, and I'm very happy with it. But I'm always for like looking over with you guys, seeing what the comments say, and then giving my final judgment. So sometimes I'm like, yeah, these points should stay off. And other times I'm like, let's put some points back on. It just all depends on how I think it should go. Oh no. Okay. Well, yeah, we'll definitely look at that. Or just email me and say, hey, Brian, look at my project, and I can do it via email most likely. So awesome. Sorry about that. We'll get it fixed up. That's the goal. If there's a problem, we'll get it fixed. So good stuff. Whatever you prefer, office hours or email, I'm good with either. You're welcome. I guess, Madeline, I'll see you. I'm going to start logging off here and get some dinner, maybe some donuts. Just want to leave the meeting. So, bye, Mom. End meeting for all.